Good morning. Welcome in the presentation for Instrumentation Engineering Basics Part 1. Few days before, we had taken a poll on social media with our engineering stakeholders that whether the presentation of Instrumentation Engineering Basics will help them to understand it better. And we got very positive response. That is why we are here today. If you would like to discuss, if any, let us discuss at the end of the presentation. Before starting the presentation, let me introduce myself. I am Preeti Raskar from Ryka Engineering Solutions. Ryka Engineering Solutions is a customer-oriented company who provides engineering services for global clients. Why we call ourselves as a customer-oriented? Because we ensure value for customers' money. We have many proven track records wherein we did substantial cost saving in the projects we did while respecting project specifications, engineering practices, and codes and standards. We are well equipped with various international standards, updated technologies, and recommended engineering practices. We provide instrumentation and electrical engineering services for process industry. Other multidiscipline services like piping, civil, and process through our business associates of same industry experience. This is the roadmap of the presentation. HSC movement. Why HSC movement? We ensure HSC, that is health, safety, and environment in every project we do. As a good practice, we discuss one HSC movement in every formal meeting and formal presentation. Let us discuss one safety movement here quickly as a part of practice. Next is scope of instrumentation engineering, instrumentation engineering abbreviations, instrumentation general content and purpose of the deliverables, field instrument basic types, control system basic types, instrumentation interface with other discipline in brief, codes and standards, and discussions. Here is a safety moment for pedestrian safety. We all walk on the road, right? So while walking, walk on footpaths. If there are no footpaths, walk facing traffic on one side of the road. When there is two-way traffic on the road, walk facing the traffic. Use crosswalks and follow traffic signals. When walking with children, walk between them and the road and hold their hands firmly. The picture shows do and don't of the rule. Distracted walking can be very dangerous. Unplug, lower the volume of headphones while walking so you can listen to vehicle horns. Do not use your cell phones until you are out of intersection. Do not greet friends on the road. Take them to the footpath or the side margin. Don't come on the main road while waiting for a bus or pickup vehicle. In Ladakh region, our BRO means Border Road Organization of India, is doing fantastic work. They built very good roads. In that hilly region, there are boards by BRO with humorous quotes on the road safety. One of the quote I remember, don't be Gyama in the land of Lama. In the same line, on the road, no use of phones or headphones, it may break the bones. So with this safety moment, we'll go ahead. This is scope of instrumentation engineering. Basic engineering. Basic engineering is the engineering done in idea generation stage of the process plant. It includes identifying requirements of various instruments and controls, identifying level of automation, and deciding on basic project specifications. Field engineering, this engineering stage decides the budget of the process plant. In this stage, bill of materials with short specifications are prepared, inquiries are floated in the market, costs are obtained, and budget is derived. Detail engineering is actual engineering of the process plant. Then under detail engineering, there are three types of deliverables. One is procurement engineering deliverables for the material which is being procured. Field engineering deliverables, those are the engineering deliverables which are sent at site for the erection and construction purpose. Then interdiscipline interfaces is the activity or document exchange between the two disciplines to ensure the interfaces required for the installations. and construction. Then inspection and expediting, inspection of the material being procured. Expediting is follow the vendors and suppliers so that materials are reached at the site as per the project schedule. Erection is installation and construction of the plant. And commissioning is starting the process plant first time with air or water trials and then with process fluid. These are instrumentation abbreviations. We often use these words. It may find as jargons, but its meaning is very simple. MR is material requisition, which is nothing but inquiry specification. PR is purchase requisition, that is order specification, one can say. TBA or TBA is same, technical bid analysis or technical bid evaluation. Vendor drawing review is VDR is vendor drawing review, VOR is vendor offer review, EDB is engineering design basis, ROV is remote operated valve, MOV is motor operated or motorized valve, SAPCV is self actuated pressure control valve or pressure regulator. LCP or LCS are local control panel or local control station. PLC, DCS, you may be knowing. PLC is programmable logic controller. Distributed control system is DCS. ESD is emergency shutdown system. GDS is gas detection system, and FGS is fire and gas system. These GDS and FGS can be is particularly same. Few clients call it gas detection system if it is only gas detectors are there. Fire and gas system is when fire and gas detectors both are there. TFMS is tank farm management system. IS intrinsically safe, non-IS is non-intrinsically safe. MCC is motor control center, and FAT is factory acceptance test for any type of systems like control systems or analyzer systems. These are instrumentation engineering deliverables. So we'll see general purpose and content of these deliverables. So these are the deliverables we'll discuss in depth. Instrumentation design basis. So this defines criteria and short spec and basis of selection. Any engineering deliverable is the language or engineering thoughts of the engineer which he or she wanted to convey to other discipline engineer like mechanical engineer, site commissioning engineer, civil engineer or control system application engineer. Hence, while preparing engineering deliverables, engineer need to understand what is the purpose of the document and how other engineer will use the information. In this case, instrument design basis is the first deliverable of the detail engineering. It is available if it is available in the project specification provided by client dedicated for that particular process plan, then it is not required to be prepared separately. This design basis generally provide guideline throughout the engineering. Next deliverable is instrumentation index. So instrumentation index consists instrument list with location, service, manufacturer details. This is instrumentation index is prepared for site contractor. This is also used by other people piping may refer instrument index, to understand how many instruments are there, or any interdiscipline engineer can refer it. Instrument IO list is IO signal list for with the control system interface details. It contains IO type, then whether it is 2-wire or 4-wire, whether it is intrinsically safe or non-intrinsically safe, what type of certifications are there, what are the ranges, what are alarm levels, location, service. So for all the IO signals, this provides all the data to control system application engineer. This is basically first input to control system application engineer. Control system application engineer requires instrument IO list and P&IDs as a first input to start work with. Then procurement activities for field instrument items and control system items. Control system can be any system, DCS, ESD, fire and gas, etc. Then material under procurement activities, there are 4 types of stages. One is floating the inquiries, that is material requisition. Then material requisition defines specifications of the material. Then after inquiries are floated in the market, vendor offers are received. Then engineer goes through the vendor offers, raise technical queries. It is responsibility of engineer to bring all the offer at same technical level. And then technical comparison and analysis of the offers is populated in the technical bid evaluation or technical bid analysis. It is submitted to the procurement basically of the client side or procurement department of the project. Based on technical bid analysis submitted to them, they call all the vendors, all are already at one technical level. They negotiate and place order to one of the vendor. After order is placed, detail engineer is informed that order is placed, and then he or she prepares define the it specific purchase requisition, which defines specification of the material post order. Then once PR is released, purchase requisition is released, then approval of vendor document stage comes. Approval of vendor drawings and documents is the last deliverable where bug can be arrested. So in all the stages, detail engineer bug can be arrested, or latest if any changes are there can be taken care. It is so every stage of the procurement activities is very crucial. Then comes process hookups and pneumatic hookups are required at site as well and for interdiscipline as well. This deliverable defines connections, means in this deliverable connections of instruments are defined on pipe or vessels or tanks. It conveys instrument side connection to mechanical engineers so that they can provide the required counterfeiting. It is also prepared for site contractors so that they can install the instrument on the pipeline or vessel as per the document. Installation sketches defines installations of instruments, stands, junction boxes, panel stands, etc. So these are the next set of deliverables. So content and purpose of the deliverables we'll see here. Level sketches defines vessel mounted instrument connections and elevations with respect to alarm set points. Alarms are very important in any process plant. They are warning signals to the operators so that they can take corrective action before failure. And to ensure that alarm level measure instruments on the tank and pipe are measuring as per the required alarm set points, level sketches are important in any petrochemical or oil and gas or chemical plants. Then installation, tender and MTO. So this is basically bill of quantities of all installation material with specifications, and this is input to site construction department, so that based on this they can raise inquiry in the market to appoint site contractor. JB is junction box. So junction box and cable schedule is there, tube schedule, drum schedule, cable list. Instrumentation, junction box and cable schedule depicts instrument to control panel connections. It indicates terminals, length of the cables, gland size at instrument and junction box side, names of the cables coming in and out, and DCS side termination details, so that site contractor or site engineer can erect them as per the document. Tube schedule, drum schedules are the schedules for tube or drum, how much tube to be cut or how much cable to be cut from the bundle dispatched at the site for the particular cable name or particular tube name. Cable list is also list of the cables with name interfacing from one location to other location. Uh, Under layout, there are main cable tray layout, instrument location layout, fire and gas layout, control room layout. In main cable tray layout, basically instruments and its cable tray route details with its location and elevations are indicated for the trays between junction boxes and control system or control room. In instrument location layout, instruments location and elevation details are shown. Main cable tray layout and instrument location layout can be combined. Then fire and gas layouts basically is for fire and gas instruments, its locations and elevations. You must be wondering why fire and gas layout for fire and gas instruments, why layout is different, and for instrument location, why layout is different. So in fire and gas instruments are located as per their installation guidelines. So those guidelines need to be depicted or shown on fire and gas layouts. That is why fire and gas layout is different. And then control room layout, which indicates panel elevations, inside trays, furniture location, etc. Now comes schematics. Instrument earthing schematics, instrument functional loop schematics is there. So instrument earthing schematics basically instrument items earthing scheme, and instrument functional loop schematic is scheme of instrument loops. Loops, what are loops? Loops are the group of instruments with respect to sequence of instruction executing in control system. So based on that, when one prepares instrument IO list, engineer specifies loop name there. Loop names are formed based on the sequence of instruction executing for those tag numbers. So loop schematic document is for control system engineer. Then comes cable block diagrams. This is cable scheme from field to control system. When there is a scope split, these between the two organization, two companies or two contractors, then it indicates the cable exchange or cable interface between these two scopes. Logic diagrams is control logic depicted in logic gate formation. See, in control system, these are the basic deliverables of any process plant for instrumentation engineering. There are also many types of control system deliverables, almost more than 20 types. These are being very vast, these are not covered here. So right now only basic engineering deliverables are covered. So next we'll move for field instrument types. To obtain reliable process information and control of the process plant, proper instrument specification and engineering becomes crucial. So detail engineering for field instrumentation include valves. How many types of valves are there? Control valves, on-off valves. In control and on-off valves, all ball, butterfly, globe, diaphragm gate valves are there. Then pressure relief valves or pressure safety valves. Special valves like knife gate valves, self-actuated pressure control valve, that is SAPCV, then motorized valves. So, so this is globe control valve, then butterfly on-off valve, diaphragm control valve, motorized valve, self-actuated pressure control valve, knife gate valve, and pressure safety valve. So few types are, shown here. So procurement engineering of all these valves includes connections, control wall sizing as per the engineering standards, materials, inspection and test. All these details need to be taken care of. Next are measuring instruments, level, differential type level transmitters, various type radar level transmitters, displacer type level transmitters, capacitance type level transmitters, ultrasonic, nucleonic, servo level measurement, and various type of level gauges. So this is typical vibration type level transmitter, then radar type level transmitters, diaphragm seal type level transmitter, then differential type electronic remote sensing transmitter. This is new era transmitter wherein tubing is avoided and accuracy of the transmitter is improved. It is very good for corrosive services. Then nucleonic level transmitters are there, displacer type level transmitter, and servo type level transmitters. Next is flow, orifice plate assemblies, various mass flow meters, vortex flow meters, electromagnetic flow meters, ultrasonic flow meters, PD meters, turbine flow meters, V-cone meters, sonic nozzles, Venturi pitot tube or anuvar. Means anuvar is a proprietary term, but the instrument's name is averaging pitot tube. Flow switches. So this is typical vortex flow meter, then PD meter, averaging pitot tube is there, ultrasonic flow meter, mass flow meter, multi-phase type flow transmitter wherein oil, water and gas flow rates are measured, magnetic flow meter, and orifice plate assemblies. Next field instrument type is temperature. There are various types of temperature elements like thermocouples, RTDs, then temperature transmitters are there, temperature gauges are there, skin temperature measurements are there, multi-point temperature measurements are there. So these are typical skin type temperature measurement. This is also skin type. Then these are typical temperature elements, RTDs, thermocouples. These are head-mounted transmitters. These are head-mounted transmitters, DIN-rail mounted transmitter, temperature transmitter, remote-mounted temperature transmitter. Then thermowells with various connections. This is one of wireless transmitter. Then these are thermowells with various connections, flange connection, threaded connection. Then multi-point temperature transmitter. This is typical temperature gauge. In pressure type, there are various types of pressure transmitters and pressure gauges. This is typical differential pressure transmitter. Then in pressure transmitter, there are also differential pressure transmitters. Wireless type pressure transmitter is there. Diaphragm seal type pressure transmitter is there. And this is, without indication pressure transmitter is there. There are many types of pressure gauges, diaphragm seal type, burden type, capsule type. Um, so there are many pressure gauge accessories also need to be worked out in detail engineering. That is overpressure protectors, pulsation dampener, siphon, manifold, and special connection types like diaphragm seal. Next is analytical measurement. Various types of gas liquid analyzers are there. Gas chromatographs, analyzer systems, and shelters. In gas analyzers, there are SOx, NOx, ammonia, CO2, O2, total hydrocarbon, etc. analyzers. And in liquid analyzers, there are pH analyzer, conductivity analyzer, ORP analyzer, dissolved oxygen analyzer, turbidity, silica, oil in water analyzer, hardness analyzer, hydrocarbon analyzer, TDS, that is total dissolved solids analyzer, and analyzer shelter. Analyzer shelter is a control room for analyzers to measure accurate reading in adverse condition. Then gas analyzers are there. Analyzer panels for analyzers are there. Gas chromatographs are there. Gas chromatographs are basically analytical measurement technique used to measure mainly organic molecules or gases by separating and detecting it. Then analyzer rack is there. So there are many complex interfaces with civil, mechanical, piping, process, electrical, with construction for installation of all these instruments. You must have seen every instrument have different connections, different working principle, different installation guidelines. So all these details need to be conveyed to all the respective discipline so that it is installed and erected at site correctly. Control system types. PLC control system is there, distributed control system is there, emergency shutdown system. These are basic types. There are a few more. Then gas detection system or fire and gas system is there. Tank pump management system is there for storage tanks. Remote terminal unit is there. Machine monitoring system, emission monitoring system, alarm management system, safety and automation system, safety instrumented system. In RTO, basically remote terminal unit. So remote terminal unit, what is the difference between remote terminal unit and remote IOs? So remote terminal unit is the controller at unmanned or remote locations, and it gives information to control system on demand. Wherein in remote IOs only remote IO cards are placed and it interfaces with one communication or two communication cable with a main control system. So in remote IO cards only IO cards are there. In RTU a whole controller is there. Dedicated controller is there, right? So safety automation system is SAS for upstream oil and gas. There are many types of system there, but only few couple of systems as mentioned here as basic. Safety instrumented system is same like emergency shutdown system for upstream, but it has a more complex and more detailing. Inside it, there are process shutdown system or emergency shutdown system are separate in under SIS. In instrumentation interface, basically let us see instrumentation engineering interfaces with other disciplines and how they interface for what purpose. So we have seen many types of field instruments, many types of control valves are there, many control systems are there. So for connection of and installation of all these instrument items, it requires the requirements of these all instrument items need to convey to other discipline engineer so that they can provide counterfeiting, they can provide support, they can provide space for that. So all these interfaces are very much required. These interfaces few disciplines delivers engineering deliverables which are input to other discipline, and a few so all those interfaces we'll see here. So it starts with process, that is chemical engineering. They prepare P&IDs, that is process and instrumentation diagrams. They provide process data sheets, line list, hazardous area classification, and HAZOP and SEAL reports to instrumentation engineer. Then comes mechanical engineer. They provide plot plan, equipment layout, piping and wall material specifications to instrumentation. Instrumentation provide instrument connections, straight length requirement or any installation requirement to piping, and they also provide instrument item details for 3D cataloging so that 3D model is built up for the plant. Then with electrical engineering, cable tray routing drawings are discussed at very first stage of the project. What are the routes of electrical instrumentation? When they are going together, they combine the support requirements so that optimized engineering is done. So there is a very close interface between instrumentation and electrical as well for cable tray routing. Then for electrical signal scheme, instrumentation also provides non-UPS power requirements to electrical engineers, then earthing requirement to electrical engineer. Then again mechanical, rotating equipment and packages. So there are equipment or package drawings and HVAC for control room. So all those kind of deliverables are conveyed to mechanical engineer. So in every package there are few few instrument items. So instrument engineer need to ensure that those instrument items are in line with the project specification, adhering all the guidelines and codes and standards specified in the project specification. So vendor drawing review is also involved for package instruments by instrumentation engineer. Then for vessels, for tanks, vessels, so all these equipment drawings are shared with instrument engineer so that instrument engineer ensures the connections are correct with respect to the instrument items installed on it. Nozzle sizes, orientation, any other installation requirement for critical instruments like level, nucleonic are being discussed in depth with mechanical engineers, and the requirements are specified on their drawings. With civil also there are many types of interfaces are there. One is control room architectural drawing, platform requirements need to be informed to civil, insert plate requirements, cutouts, support for cable trays, Trenches and hume pipe requirements need to convey to civil structural for installation of instrumentation items, cable trays, any big, systems. Then installation tender is prepared for construction. Site queries, if any, are answered by instrument engineer. Many times, sometimes it happens at site that few routes are changed based on site requirements. Then accordingly, instrument items need to be relocated, reshifted. It happens very less time, but then such kind of site queries are there. So let us move to codes and standards. Indian standards, IS is Indian standards. International Society of Automation, International Organization of Standardization, Petroleum Explosive Safety Organization, PESO, International Electrotechnical Commission, National Electric Code, the American Society of Mechanical Engineers is ASME, American Society for Testing and Materials ASTM, American Petroleum Institute, oil oil industry safety directorate. So these are typical basic standards. There are few many. You can check on our website as well. So there are many standards. Generally, Indian standards, ISA standard are basic standard. Indian standards are used when project is getting installed. Project is from India, but these are specified in the project specification, basic tender specification prepared by client based on which they want, put up the plan. Generally, IEC are for European countries. Then NEC is for North America. SME, STM are for mechanical connections and all. ASME and API again for pressure vessels and pressure equipments like pressure safety valves or etc. So all these codes and standards are very very important while executing or detail engineering in every project. We are open for the discussion now. I can see few questions in the chat box. Uh, what is difference between RTO and remote IO is the first question. As I explained earlier, RTO is dedicated controller which is located at unmanned or remote location and which interface with main control system on demand. And remote IO cards are the only IO cards located remotely and interfacing with main control system on communication cable. Next question is which level transmitter shall be used if foam is there? So if foam is there, generally radar level transmitter is used, but there is many process parameters need to be studied thoroughly before selecting any level transmitter. Next question is, okay, what is criteria to select any level instrument? The type of any instrument or wall, one need to study design conditions, transient conditions, then process conditions like pressure, temperature, viscosity, and density. One need to also check the fluid properties, whether it is erosive, corrosive, toxic, what is its build-up tendency, whether it is solidifying, whether it has suspended solids. If yes, what is the particle size, hardness of the material. It also need to check with respect to working principle of that particular instrument, whether it will work on the given process fluid. What is installation criteria of that particular instrument? Then design requirements, project specific requirements need to be checked. Certification requirements need to be checked. So all these engineering need to be thoroughly done while selecting any type of instrument or suggesting the type of instrument. Next question is what is duration of the project? So duration of the project may vary, depends on the quantum of the project. Latest big project we executed of for 6,000 diodes, 3,000 instruments. We instrumentation engineer generally speaks in terms of IOs and number of instruments. In that particular project, there were 135 EP100s were there, and we consumed almost 16,000 engineering hours on that project. Duration of such big project may vary from 1 to 1.5 years. And if quantum is less, then engineering duration may be 3 to 6 months. We generally stick to the project schedule provided by client, provided it is realistic. There are also certain fast track projects. There is certain way to execute them. In such fast track project, input requirement is also fast track, and vendor offers are generally evaluated across the table in such projects. So we generally stick to the project schedule, but it also depends on the interfaces of various disciplines and inputs provided uh, to engineering. Are there any more questions, or you would like to discuss, if any? You can always mail me your queries. My mail ID is provided on the next slide. Thank you. So this is the end of the presentation. It would be our pleasure to be associated with you. Please let us know if any. Here I have specified two quotes. Why? Because during engineering, any missings, absence of interfaces always results in overrun of the budget and delayed project schedule. It is very important to have good engineering expert while doing such projects. So it says it takes 20 years to build a reputation and 5 minutes to ruin it. If you think about it, you will do things differently. Warren Buffett. Words may inspire, but action creates change. Simon Sinek. Thank you. Here, I have provided my contact details. My mail ID is there. My phone number is there. Please visit our website. There are knowledge sharing papers are there. For example, jacketed instruments, field instruments on jacketed line, then communication control system communication protocol. Uh, Follow our LinkedIn company page. We do post updates of projects, company, launch of any training video or podcast there. We also have YouTube channel. Follow and subscribe it so that you will get notification of the new post. Video section of this channel deals with awareness of instrumentation engineering in the process industry, and audio section, that is podcast section of this channel, experiences regarding life skills, humanity are shared. So thank you very much. Thanks a lot for your time. Thanks a lot for your attention. Thank you.